In any programming language, we see kind of how much it provides explicit and how much it provides implicit, means how much it does the work behind the scene and how much work it does uh, kind of means in front, means there is nothing hidden. So like we discussed that in Python, Python is generally preferred because most of the thing is data structure based and it's explicit, means we just need to kind of get the a handle or reference to the data structure, module, function, class, whatsoever, and then we can manipulate over it. Means it's a completely explicit. There is a very few things that are hidden, like we talked about methods, how we create the method object from the user defined function. Okay, so now the story of implicit and explicit in the programming language, that we saw that we need explicit. Means if we implicit is required when language takes the control, okay, and explicit is required when programmer takes the control. So if programmer is powerful, then certainly language has to provide a mean to kind of to get something done or most of the thing done explicitly. So if we see now the 3D graphics through OpenGL, earlier things were implicit, means it maintains states and then it provides a lot of APIs, and if someone calls, then everything happens behind the scene, okay, not outside the scene. So that is kind of traditional way of doing the OpenGL programming. Okay, it is also called a fixed function pipeline. Now, when kind of after the introduction of shaders language, like a geometry shader and a fragment shader, or we can say pixel-wise shader. So each pixel color, we said we don't call it pixel shader because whatever color we set for each pixel, it is not guaranteed that pixel will go into the color bubble. Means that pixel will get kind of kicked out because of depth test or stencil test and so many tests. Okay. So, but still, if we see kind of shaders, then in geometry shader also, in fragment shader also, means we have kind of a full control, especially in the light calculation. When we go for a lighting calculation in OpenGL, then all the vector calculation and the light calculation, everything a programmer can do. Means if programmer is expert, if programmer knows kind of mathematics very well, then he can do good amount of thing in kind of fragment shader, not require the kind of the implicit way of programming. Like lighting model, we have to specify lighting model. Now, a specular color, the shining of the specular in the lighting, it will happen after the texture comes into the picture. It is one-sided, two-sided. Then the calculation of the lighting will be near, where it is local or remote. Means so many things. Means it's a kind of mesh of states. Then how many light model we can specify, maximum 16 or 8. Then each light model we have to specify kind of material property. Then internally it will do a multiplication with the material property and the light property. If multiple light sources are there, then each calculation then it would too much, means that much implicit is too much. So OpenGL kind of it came forward and it brought kind of a shader. So shaders language anyway, it is useful when it comes to kind of a GPU kind of calculation, where the mathematical calculation goes to a graphical. But apart from it, still the calculation is in hand of programmer. So programmer in the kind of fragment shader, it can do all the kind of calculation. It's in hand of programmer. So it's like a Python kind of a calculation where things are becoming explicit because of the shader programming. Okay, but still the way we reiterated that still in Python there are few things that are still hidden, like from the user-defined function to a method conversion. Still in OpenGL also few things are hidden. Okay, like in the lighting, the things that is hidden is backside lighting. means I have a kind of sphere, like I have a sphere, then this is outside and this is inside. Okay, then how we do the calculation of inside and how we do the calculation of outside. So generally we go for kind of normal. So what is the normal of the each surface? Means there is nothing like a surface, means whatever the normal comes into the picture and the light vector. Okay, then how we manipulate, and that the way we think about the surface color. Okay, so that happens means everything is there is nothing front or back, depending upon the kind of normal vector and the light vector. We think about the color of a surface. Okay, so in OpenGL, still the way we talk explicit and implicit. So if we consider the shaders programming language, explicit language, where we do all the mathematical computation, but still few things are still hidden in OpenGL when we go for the surfaces drawing. So typically in lighting calculation, we see kind of, I won't say glitches, but a weird kind of behavior when we go for lighting calculation of the front face and back face. Okay, so sometimes we kind of like moon kind of simulation, where if light is not falling directly on the surface, means the surface that is getting hidden, I won't say it is a back surface, like if it is a sphere, lighting is coming from here, then back side will not get illuminated. Even though it is in a depth test, it will come in the front, but still it will come in a kind of ambient calculation. So if we do kind of these kind of calculation, but still sometimes like if we go for transparency and those kind of calculation, it is showing some kind of weird behavior. Means I would say it's not something that would be expected. Okay, so now we'll see kind of how whatever is implicit in the OpenGL, that are state management and the shader. So how kind of their relationship, or it's a kind of the synergy between them, how it happens. Now if we see about kind of discrepancy, so discrepancy when it comes to the lighting calculation in the front surface and back surface calculation, which leads to a kind of a weird problem that we'll see how we can get rid of it. So typically like we can use cull face. So we can cut a particular face, front face or back face of a kind of a particular surface, and then we can get rid of many kind of weird behavior that we'll see. But in addition to that, we see that how we can make synergy between the OpenGL shaders code and OpenGL Python code or C code outside, so that whatever we draw in the shaders code, how it goes finally in the kind of the backend source, and they do the manipulation. So we will focus on kind of the discrepancy, what we see in the face, back face and front face drawing when we do the lighting calculation, and then we get a kind of a remedy of it through the cull surface, and how we do the synergy of the cull surface or any kind of state management in OpenGL that will do the kind of the harmony relationship between the shader code and the backend, the Python code. So that will